Hi, welcome. Do we have next guest? Okay, short introduction for our guests. I'm Evgeny Leib. I'm development manager at Wix, and one of the projects I'm working on is to check how we can extend the usage of Google Cloud Platform for additional services. And we do this presentation together with Dimitri, lead of our system team. And today we will take a look at what new technologies were released by Google in just compute stack. Originally, actually, we planned to do this presentation to present all new technologies, including databases, big data, etc. But we understood that we cannot cover all of them. It's too much to cover in one presentation, and we decided to split to several. And today we will focus on compute stack. This is a picture of Google Cloud Platform and technologies, and on different segments, how we divide them. As I said, today we will cover the compute part, including computer engine, container engine, managed VM, app engine, and green light. We selected the new technologies which were released on last year. Actually, we started pilot and we play and do several POCs in all of them. Also in the several technologies we are not listed here because they are not publicly available now. And let's talk about compute. You probably know about App Engine, and App Engine was released about, I think, 5 years ago, maybe more. And the compute engine is also it's known and commonly used. Compute engine. This is very similar to Amazon. Compute engine represent infrastructure as a service. And App Engine, this is a platform as a service. And what is the difference between them? And what, in general, why we want to use a cloud platform for compute? What do you think? What is main motivation to use cloud platform?
Because Google.
Okay, this one. There are some motivation, including elasticity, that you can, if you have the peak in your traffic, like we will have now with our Super Bowl campaign, you can spin a lot of machines and close them, but you don't need them. But probably the main reason is to do minimum minimum work in order to run your service, in order to create your service, in order to run your service. We would like to delegate as much as possible of operation work to cloud provider. As we, for example, when we today do our on-premise data center, we do not build the electricity station. We get electricity from provider. Why we want to install machines? We want to outsource this. Why we want to care about upgrades to operating system? We would like to outsource this. And cloud platform enables us. The cloud provider takes a part of the operational work usually we do, and do it fast. And App Engine, this is a good example when a cloud provider takes from us almost all operational work. We write our code, we're writing using one of the languages and runtime supported by this platform. In this case, it's Java, Python, PHP, or Go. We submit our code to Google, and Google decides when to run it, how to run, how many instances depending on traffic, on which geographic location, how to monitor it. If the application stacks, it will create another instance and will close the instance of application. It is fully managed. It will do auto-scaling, load balancing, and also will provide a rich set of services, external services we can use to store data, to store logs of application, to monitor application, to process our data, to do asynchronous messaging with other services, communication with other services, etc. Looks very simple, very good, but it also limits us. In this option, we have maximum agility, but we have minimum flexibility. We can choose other languages. We cannot choose other platforms. For example, App Engine, if you're talking about Java, it's based on Jetty web server. If you want to use other web servers, we cannot. Application is run on doesn't provide full access to operating system. You cannot write to local disk. Your access to system resources are limited. But from operational point, this is you almost don't have any operational aspects. On the other side, you have Compute Engine. Compute Engine is infrastructure as a service. You have hardware provided by Google, and you can run virtual machines you create. You can run anything. You can do anything you can do in any virtual machine. Actually, starting from this year, Compute Engine also can provide you auto-scaling. It will create additional virtual machines depend on as response to high load on your system. It will do load balancing, but you will have to manage entire stack. Let's take a look at example of application in the Java stack, Java Scala stacks that we are using here. We have server, we have our operating system, Linux in our case, we have Java runtime, we have web server, Jetty, we have libraries and external binaries, for example, New Relic agent, which is installed on the system, and we have our application. On Compute Engine, Google will provide us and will manage just a server, just the hardware of the server. We have to take care of host operating system, Java runtime, web server, libraries, application. Everything should be managed by us. We have to install operating system. We have to patch, to install security patches. We have to manage upgrade processes. Everything on our responsibility. Maximum flexibility, more work. On the other side, App Engine will provide us everything, excluding our application. We don't have to install patches on operating system. We don't have to install patches on to upgrade Java runtime. We don't have to upgrade web server. Less work, less flexibility. We cannot upgrade. We cannot decide when to move to Java 8. It depends on the platform. When Google will decide to move to Java 8, we will have, just as we will have possibility to use it. Until last year, we had to choose between these two possibilities. Or we use compute engine, or we use app engine. In compute engine, we manage VMs, we do all operational work. On app engine, fully managed by Google, fully restricted by Google. For some application, it's okay. And actually, we have a few microservices at Wix, which is created using App Engine. For some of them, it doesn't provide what we need. For example, App Engine does provide logging and monitoring, but it is less advanced than New Relic, for example. And we can use New Relic on the classic App Engine because you cannot install New Relic agent. Good news from last year, we have two new technologies. One of them is container engine, and second one is managed VMs. Both of them are based on containers, and specifically they use Docker, and we will talk about Docker, a big part of the presentation today. And there is a big overlap between this technology, and it looks like both of them will converge to one product in the future. But today we have container engine, which is containers management system which was developed by compute engine team. And we have managed VM. This is also, we can think about it as a containers management system, which was created by App Engine team. A lot of overlap between them. We will deep dive today in both of them, and we will see what they have common. We have two pilots that we will present at the end of the presentation, and what we find that we have missing, for now we have missing features in both of them, and everything that we miss it, we don't have in managed VM, we have in containers engine, and vice versa. We hope that until the end of this year, we'll have one platform that will provide us everything. Short overview about container engine and managed VM, and we will, before we deep dive to Docker and then to containers engine. And container engines is the management of Docker containers. It is declarative. You define and layout of your service in JSON files, and you ask platform, containers engine to create your topology and to manage it. It will create and deploy all containers required for this. It will monitor them. It will do auto-scaling. Currently, it's not implemented, but it will be released very soon. It will do load balancing. It will take. It will configure not just the container, but also topology of network for communication between your services. It will do health monitoring, and yeah.
When you talk about auto-scaling, how does it work? How does it know when to scale up or scale down? Do you want to just elaborate a little bit?
Yes, we'll talk about this when we will deep dive, but on high level, today it can be in containers engine, it can be done just according to CPU usage. From next version, they will provide possibility to define your own metrics. Your container will expose the interface. It will be pulled by the platform, and according to information that you provide to the system and logic that you define, it will create additional instances. Also, according to your logic, you can specify minimum, maximum, time. You have a lot of parameters to specify. Very important point about containers engine is portable. Containers engine is based on open source project called Kubernetes, and currently it supports Google, Amazon, Microsoft Azure, CoreOS, Mesos, and I think about 5 or 6 additional services and platforms, including on-premises and cloud. And you can manage your system regardless of of your actual provider. You can use same images of containers, same configuration to deploy your system to Google, and to deploy your system to Azure, and to deploy your system to Amazon. For us, it's very important. All other technologies for now do not provide this portability. If you use managed VM, you have to create everything you do will work just in Google.
Managed VMs don't use Dockers?
It does. It uses Dockers, but it's not portable. And actually, you don't. For managed VM, you don't provide Docker image. You provide Docker file, and Google will create an image for you, and Google will manage your image for you. It will do updates of operating system. It will do updates of libraries, and if you'll go to this slide, actually in managed VM you can, Google will manage your servers, of course, it will manage your host OS, and also you can, with regards to all other part of stack, you can choose. You can take an runtime provided by Google. For example, Java runtime, web server, Jetty. You can Google also will provide you libraries to access to other Google services, but you can override them. You can decide you don't want to use Java 7 runtime, which is currently provided by Google, and override it by Java 8. In this case, you take responsibility to manage it, but you can. This is the same is about web server, and you actually don't have to use runtime and language. You're not limited to use Java or Scala. You can use any runtime you want. For example, today, Node.js, you have images, Docker images that you can use for Node.js, and we'll demo it today. Yeah.
If it's container manager, managed VM and container engine, why do you have the web server stack? Because a web server can be a container. It doesn't have to, like, what do you benefit of letting Google manage VM and manage your web server if you're going to deploy containers into it?
You don't deploy containers.
It's not the web server. It's the Java web server. It does run inside your container. The option here is to choose if you want to run the Google provided and configured and supported Jetty, or if you want to run Tomcat.
Yeah.
That's the point.
Or, okay.
Okay, now let's talk about Docker and managed VMs.
Docker, as Evgeny already mentioned, all the technologies we're discussing today, including managed VMs, containers, and everything, the building block is something called a Docker container. Who used Docker here at least once? Okay, not a lot of people. You lie, you didn't. Now, what is Docker? Docker is a concept, a new concept of level virtualization, because like in the previous slide where you chose your level of control of your application, the same way you can choose your level of your virtualization when you run something on your box. So in a typical setup with virtual machines, like what happens on Amazon, what happens with VMware, what happens with Vagrant and VirtualBox when you use them, is that you have your host operating system running on hardware. Then there's a hypervisor layer, which allows you to run one or multiple operating systems upon the hypervisor. Like you have you can run two or you can run one, you can run tens of them. But the idea is that you still have an operating system running, you have the libraries, and you have your application. What happens in case of Docker is that you have your server, your operating system, something called the Docker engine, I will elaborate a bit later, and your app running on top of it. You don't have the operating system layer for your concrete application, but it's not really reusing the operating system. The only thing they actually share is the kernel and the APIs which the Docker engine provides for the image to run. Now, what Docker is? Docker is a library. It's built of multiple parts. Docker is a system. It's a framework. They have a Docker runtime, which is the actual daemon, which runs on the servers and runs the containers on that. They have the libvirt library, which is written in Go, which replaces Linux native LXC container visualization library. What it does, it uses the native kernel calls of C types and what's the second one? C groups. Which allows you to run a process on your operating system, but encapsulate it and close it down to a smaller subset of functions it can run. And
it's the namespace. The C groups only managing the accounting for CPU and memory.
Yeah. Okay. So what is provided by namespaces is allowing your app run without seeing the whole operating system. And the C groups allows you to, from the outside, to control the amount of power, CPU, RAM, disk I, or whatever you allow your application to use. So the Docker daemon controls the containers. The Docker client is just the CLI command you use to interact with the daemon. The registry is something like what you've seen in Amazon, for example, like the images of virtual machines. Docker uses the same approach where when you build images which you then run. The difference between virtual machine images and Docker images, that Docker images behave very much like Git repositories. When you build and upgrade a Docker image, every change is saved. When you, for example, upload it to the registry is a repository for Docker images. When you upload it, you only upload the delta. And when someone pulls your image, if he pulled before, he will only pull the delta. So you don't run around with a 2 giga virtual machine image, which each update, you change one file, you need to build another one. Here you have incremental updates, and you can actually fork, you can reuse other images. For example, when you build an image for Java, you can probably start from a default Java image, which Oracle, I think, provides right now, or someone builds them. Or you can start from a fresh Ubuntu image, and then just apt-get install Java on it, or install Java any way you like. And then it's a tree-like structure, any Docker image. Docker container is the instance which runs something which is on the image. The image I just discussed. The Docker file, I will show an example later. The Docker file is the definition for Docker on how to build your image. Okay.
Question.
Answer.
You're saying that it's not a real fully functional OS, just a limited.
It's not an OS. It's you run on basically you can run an OS there. People do that. It's not impossible. It's just kind of, in my opinion, against the Docker idea. In Docker, you run one process, which has around it all the libs, all the processes.
But what
again,
about OS services? What
like
are
what?
Limitations? If I write I don't know. I write some software that relies on some service, on some OS daemon, for example.
First of all, you can communicate with it outside if you wish. There are possibilities to do
Outside
that. Plus, no one limits you to run in one process. You can actually run the daemon you want, like NTP or whatever.
I would use that in another Docker?
No, you can use it. You can have it in the same Docker. You can use it in another Docker. Usually, Dockers are split per application, so you run one application in a Docker instance. So.
A word about state. I mean, there's this concept of Docker image. You have the application that runs. It accrues state, right? It writes logs and shit. So
this is not actually a concern of Docker itself. There are ways to work with it. Actually, the basic given, like same as on Amazon until up a few years ago. Your data on your disk is ephemeral. Everything you wrote when you go down goes away. There are multiple ways to work around that. First of all, you can mount, when you run a Docker image, you can mount some portion of a local disk inside your Docker and right there. Other ways to do it is for running another Docker image, which manages the disk. It's usually a BusyBox image, which the only thing it has is its disk, and it shares it with other images. There are ways around it, but basically your local data is non-existent. It's not persistent, unless it's mounted from the outside. So keep data outside.
Yeah, you've implied that Docker containers can be not shared exactly, but sort of intermixed. Like you just mentioned that you can have kind of a JBOD style Docker image, like a disk container.
This concept of integrating Docker images together into some entities like services, pods, and everything will be discussed later in the cloud Google Kubernetes engine discussion. That's what they do. That's what they build upon. Now, this is an example of a Docker file. From means the image you inherit from. As I told you, that's it's all based on inheritance and diffs. So you inherit from Ubuntu. It means that when you start building, you get a fresh, latest Ubuntu image with nothing running, nothing installed, and you install your whatever. You can use run commands to install anything you want on that machine. This is actually it's just a setup to have Node.js and Python on your machine. This is all the setup phase. Now, what the add command does is when you run it inside the Docker is run inside a directory, and add means add this file from this directory or this path from this directory to the image. It copies it inside the image. For example, your application.js file. And the CMD thing is explains to the Docker, when Docker boots the container up, it knows that it has to run this as the command line after boot. This will be the actual process running inside Docker.
It defines a lifetime of your container. When this process exits, container dies.
Yes. There are, as I told you, you can mount a volume. With the environment variables are a very big part of a Docker thingy, because that's the only viable way of passing configuration inside your Docker.
Mounting. You can mount a config file.
You can mount a config file, but this is already kind of...
This is the suggested way.
This is the canonical way is environment variables. So if you need a DB connection or a string, a URL to another service, or some string for encryption key, your application should be getting them from environment variables outside of Docker. The before mentioned Kubernetes engine relies heavily on it because inter-pod communication, inter-service communication there happens based on environment variables. So this is the build and run process for a Docker deployment. You have a Git repository with a Docker file. The Git repository is actually optional. You can just have the Docker file. Usually the Docker file would sit just in your application code, because the Docker image is your new deployable. It's instead of a war you've used to build or a tar.gz, you end up with a Docker image at the end of your build. So the Docker file usually resides inside your source code. So in the build phase, you have the one big limitation of Docker is that it only runs on Linux, and it only runs on Linux with a kernel version more than 3.12 or 3.18. 3.8 is not very stable. As such, you need something even more. So it only runs on Linux with a specific kernel. If you want to run it on your laptop, you have solutions like boot to Docker, which actually boots a small VirtualBox machine, which the only thing it does, it runs a Docker daemon and I also think a Docker registry. No, actually not. It just runs a Docker daemon, which allows your local Docker thing to interact with a live Docker instance on a Linux machine, which runs in a VirtualBox on your machine. So Docker, no, it's the kernel. Boot to Docker. It will not run on Mac because it doesn't have Linux kernel at all. So what happens is when you do Docker build, it goes according to the Docker file, installs stuff, adds stuff, pulls stuff. Then it creates on your Docker engine running besides, it creates an image with all what you defined, and you push it to the Docker registry. Docker registry, as I told you, it's a storage for Docker images. Then what happens? This is already the deployment part. You have a host which runs your application, for example, one of the app servers, which has the Docker engine. And what happens there is you say Docker run, and you point to an image in the registry file. It pulls the image, it runs the image, and you get a running container on your machine. There are multiple ways of automating this process, because what's drawn here is quite manual. There's Koros, there's Kubernetes, there's Fleet. There are a lot of solutions are being built right now. None of them is yet the solution to use. None of them, unfortunately, is also perfect. But today we're going to talk about Kubernetes mostly. These are just Docker commands, for example, like for pulling images from repositories, running, getting the logs, whatever. Okay. Any questions about Docker itself right now? One, two?
Yes. I want to know if I'm running multiple Tomcats, let's say, on the same virtual machine. Can each Docker can get its own IP, or I have to run different ports, or how can I do it?
Docker networking is actually. Do they need to intercommunicate?
No.
They will. Probably the easiest way to do it is to run them on different ports. So you don't. So just from outside, you see different ports, and the Docker daemon will set up. They have a networking daemon there, which sets up port forwarding into your Docker image.
And if I need a same port for all?
I'm not sure if we need the same pay for all. If you want every one of them to have the same port,
I can. So you can bind to a different interface.
You can just have fake interfaces with different IPs and bind each instance to that IP, and that IP will expose the port.
It is possible.
Yes. Anyway, you can't have multiple Tomcats running on the same machine, on the same port, on the same IP. It just doesn't. You can, but that's messed up. You don't want to go there.
Dimitri, can you summarize what Docker provides us, like what we had in the first slide?
Okay. So basically, what Docker provides, the main thing you get is something which you can some image which you can run both locally on staging, on production, on Google Cloud, on Amazon Cloud. You have the same code. It's somewhat close to the Java philosophy of run anywhere, but what?
Write once, run nowhere.
Write once, yes. This is build once, run nowhere, because most of Docker images don't run anywhere. It gives you a building block for your application infrastructure. For scaling, for testing, for shipping them to outside customers or whatever. This is somewhat true if you compare Docker. The higher density and more workloads is somewhat true if you compare Docker with virtual machines. But if you actually compare Docker to running the same thing on your host machine, it's just more overhead. But the beauty of it is that you don't actually need anything anymore from the host machine. You don't need a Java installation. You don't need to know what operating system is running there, whatever. Because the Docker you provide yourself the whole runtime around yourself. This way, you don't really care what is installed, or, for example, it's really beautiful for Java version upgrades. You build a new image with Java 8, you deploy it to one host, you see how it runs. You don't need to update Java, you don't need to conditional it. You run with this, you run with this. This Docker image runs Java 8. Another runs Java 7, you just can interswap them without any, so that gives, that eases the management of the infrastructure which runs that a lot, because you don't need to install anything actually except the Docker runtime itself. Plus, we're talking about Google and cloud platforms today. Docker gives you a possibility to deploy your code almost automatically with auto-scaling and everything on cloud platforms, which you can't just do with Java. They have some solutions, but with Docker, And also, the beauty of it is that you can, your outside customer is actually agnostic to what you run inside. You provide him with HTTP interface. In our case, it's usually Java, but if someone wants to run Node.js, which responds with the same APIs, which is compatible, right now our deployment system can't allow that. But if we're talking about Docker, just give me a Docker image with whatever you want there. Common Lisp. I strongly recommend Common Lisp. No, Common Lisp. Let's go hardcore. And from the outside, for the operating system, for the balancer, for everything, it doesn't care. You just run whatever you gave us. Yes?
You said that each Docker image run on a process of the hosted machine. Am I right?
Yes.
Okay, so does it mean it uses one CPU, it uses more than one CPU? I mean, as far as...
actually, the process, you can control the amount of CPUs you give to it. You can control the amount of CPU power you give to it. But the process itself, your application process, actually, in the end of it, does run on the host operating system. It just dropped into virtualization and kernel magic, but it's actually a process, so it can use multiple CPUs. Yes, of course. It's not, because it's not virtualization, you're not bound to your virtual CPU or the CPU which you're bound to. So.
There is no way to limit, for example, I have this Docker and I wanted to use a certain amount of resources.
Yes, you can. That's what C times are. C groups are for. You can limit. You can say that this process has access to 1 giga RAM, and it has access to 50% CPU. And the operating system, Linux itself, will not provide you more. You will see this as the maximum you can get. Now back on track to the managed VMs.
Monitoring-wise, the new relic agent recognizes the Docker instance as for example, you assign it a single CPU. Would it report statistics of the actual physical machine or the...
This is a bit tricky because actually, if you run the New Relic agent itself on the host machine, it will not see any applications. It will monitor the hardware, all right, but it will not see any running instances. What you do is you run the New Relic agent in the Docker, and in case of Java, benigut le PHP, that you do not need the New Relic agent to run on your machine to report. So
physical machine.
No, on any machine. New Relic doesn't need the agent. New Relic Java doesn't need the running agent. You just add it to the agent to the GVM. So you add it to the GVM in Docker to your run string. You just add the Java agent New Relic jar.
I see a graph of memory usage percentage. Do I get it? The 100%?
You don't. For application monitoring, you can't see memory usage percentage.
No, I can see how you memory utilization of the server.
Okay, you will see your real utilization, and the maximum will probably be the amount which C groups allow you. The maximum you can see. That's going to be your 100%.
From experience with the LXC, don't trust it. It usually sees the host. It sees the host totals, and you see the
physical host.
Yes, it's don't rely on it.
We never trust anything, don't worry.
Including the stock.
Fuck the stock. Now, managed VMs. Managed VMs, as Evgeny already said, is the solution to having a custom backend for your App Engine application. because original App Engine, you just give the code, you don't control anything. With managed VMs, you can get several levels of control of your application. You provide the runnable thing, and the Google managed the whole hosting environment underneath it, like the host operating system, checking the health of your application, monitoring, CPU limits, CPU monitoring for autoscaling itself, and OS updates inside your Docker image even. If you have an operating system where you do have some operating system, but it will manage that. What happens is when you use managed VMs, I'll show it later, you use the base image from Google. They give you, here's our managed VM Java image, use that, we have a lot of stuff there, enjoy it. The App Engine way was when you have, here you have user code, and everything else is provided by Google somewhere. Actually, as I understand, they migrated part of their infrastructure to run on the same managed VMs, but they just build the VM from your code and run it. As I understand, they want to migrate the whole App Engine stack to use that. But in the VM, as discussed previously, you can have user code, web server, and the standard runtime they provide you. You can actually use a different runtime, but you will get limitations on API usage from Google. The main thing that you get from the managed VM, from running your code on managed VM, is that you get almost the same level of access to Google APIs like storage, BigQuery, search, all of their cloud services which the App Engine application use. You get all of them, but with running your own code and your own server. This is an example of the configuration. It's really, really easily configured. I'll show you an example of a Node.js app later. So just to your App Engine configuration config, you can set up the machine type you want to run on. You choose which instance type your application will run on. You will, in managed VMs, you get one instance of one application on one virtual machine. It's a guarantee. So you get to choose the instance type, and you can choose the autoscaling. Autoscaling is currently based on CPU usage. So when you define how many instances you want to start with, what's your maximum, it just boots more virtual machine and installs your application based on CPU usage on the main one. It's actually really, really menacing limitation, because we would usually want to scale based on throughput, but that's not currently an option, but it is in the roadmap. This is a comparison table between what you get on App Engine and managed VMs, because in the end, the API is quite similar. On App Engine, Google controls your application start. They have their mechanism to run in your code. It boots almost instantly. On managed VMs, it depends on how fast your application starts and how fast the VM starts before your application. So it can take minutes to boot new instances when you scale. On the other hand, you have a huge request timeout. You can run really, really long running transactions or long polling or whatever you want, because App Engine will cut you off after 60 seconds.
It's not configurable? You cannot change it in App Engine?
In App Engine, no, it's the maximum. You can, I think you can lower it, but you can't make it higher. In App Engine, you can run background threads, but via their API, and it's kind of messy. on managed VM, because you run on almost on bare hardware, you can run whatever you want. Background processes are not an option on App Engine. You can run whatever, once again, you can run whatever you want on your managed VM. They have the same, almost the same scaling capabilities because Google controls that aspect. You don't have access to programming language. They have multiple, on App Engine you have multiple, I don't remember what BASIC does. I think it's just click to add or something like that. It doesn't monitor anything. And you don't have local disk at all. You can't even write a temp file. Here you do have a local disk, but as we talked, it's Docker, it's ephemeral. Google can kill your instance anytime and you will never get it back. You can customizable serving stack. What happens on Google App Engine, you give the code, it runs inside their run and they serve HTTP. So you don't control anything on the level above your callbacks. While on managed VMs, as I told you, you can run anything, any stack. You can have your own web server. You can put Nginx. You can put caching there. You're free to choose your weapons, and you don't have any runnable binaries. Actually, you just have code on managed VM. But they do patch up their runtime. You get all of the discussed above, you do get on managed VMs because freedom Docker all around. Containers engine, I'm going to pass to Eugene. Right now, I'm going to show you an example of how easy it is to set up and run an application. Now, this is an example application. As you can see, it has a Docker file defining only the one and only thing we need in this case is the parent image, which is Google Node.js runtime. They provide the Node.js runtime themselves. The application itself is the simplest App Engine. The simplest Node.js app you can run. It just responds to 2 endpoints. This endpoint is used internally by App Engine to monitor your application's health, which means it uses that to know if your application inside your Docker is okay to receive requests. It's akin to our is alive solution. And the hello controller is the first Node.js code I ever wrote. And the last one, I hope, which just responds hello to a responds world to /hello. Now, the package JSON is some sort of Node.js magic, I don't know. It actually defines dependencies of your application. In this case, we depend on the App Engine Node.js libraries, which Google uses to run. And the application YAML, which is really, really simple. We defined that we want a custom runtime because we run on the Docker thingy. We defined that we require it to be run on a VM. And we define manual scaling with one instance. The simplest thing, as I showed you before, you can define auto-scaling the same way in your YAML file as you would do in XML. That's about it. And I think the app is already running somewhere in my machine. Okay, anyway, what you do to run is, that's deploy. You run the gcloud preview up run command. Gcloud is the whole Google Cloud Management software. Preview, because Google App Engine managed VMs is still kind of beta. It's not a mainstream product. App, means that it's the app engine, and run means run. So let's see what it does. Ooh. Okay. Now, that's the log of the application. Right now, it should be running somewhere on localhost. Yeah, cannot get slash because I don't have anything mounted. Hello world. That's the app running inside a Docker container. It runs actually right now. What it does. It used my local running boot to Docker with Docker, and it booted up the App Engine SDK runtime. Right now, I can see the running instance. I can see its stats. I can view the data store and all the services the SDK gives me. That just links to the application. Okay. Can I see more stats here? No. Anyway, that's the same thing you would see actually on production with all the data, with real instances and real. I tried doing their deploy, try to deploy it to our cloud, but it failed miserably for some reason unknown to me.
You have to set your default project, okay?
I do have set up my default project because pushing image to Google Cloud. And now it will fail miserably because right now it's stuttering from my iPhone. And I'm almost out of traffic right now. That concludes the demo. As you can see, running it locally, it's quite easy. Running it remotely requires to upload stuff, so don't do it from your phone. Actually, don't run it locally from your phone too, because it downloads the base image to run, and it's a few hundred megs. You don't want to download it from the phone. Okay, let's keep.
Also, your phone isn't running Linux. Usually.
I'm happy it doesn't. I'm happy it doesn't. Nothing beside my servers should run Linux.
Before we start with Continuous Engine, a few additions to the managed VM. There are few services built in, very cool services built into managed VMs. One of them is called Cloud Debugger. You can upload your code and you can set breakpoints in your. Now it's supported by Java runtime and I think by Python. You can set your breakpoint and upload it to production, and on first real request which will hit your breakpoint, you will get a snapshot that you can continue to debug on your system. Actual request will continue, but you will get a snapshot that you can debug later.
Debugging in what? Which
Debug your Java code.
Like remote connection with API?
Yeah. No. You have an entire web debugger.
Like a core now?
Yes. They have Cloud Trace is also now included to App Engine and also for managed VM. It's provide functionality similar to New Relic. You can measure time of your request, and for each request, how much time you spend for external services like data store, query, PubSub, etc. And I think that's all. Container engine. Concept is similar to managed VM. This is a system to manage your Docker containers. But in contrast to managed VM, you provide an image. Your image and you manage your image, you manage runtime, you manage your application, you manage your libraries, you manage your client library. You can access to Google App services using client libraries they provide, but you have to find a way to get credentials and to store them, etc. It's less convenient than in Managed VM and App Engine. How it works. I already managed that it's managed in Kubernetes, open source project, and in order to use the system, you have to create cluster. Cluster includes nodes. It includes master node and includes worker nodes. How you create it? We have command line here. It's very simple. gcloud preview, like in the same command line tool for managed VM. Container clusters create. You kind of have to specify zone in which data center you would like to create it, machine type, and number of nodes. That's all. Now, once you run this command, you have your cluster up and running. You have master node, which is responsible to handle your request, your management request, and master node will take responsibility to schedule your containers to the worker nodes and to manage them, to monitor them, to autoscale them, etc.
Each run its own machine, or they're all running on the same physical machine?
They are different virtual machine. About physical machine, it's not under your control. Like it works on top of compute engine. You have to specify, like in compute engine, the size of machines, and for each node, it will create a virtual machine according to what you specified. You have machine type, G1 small. The G1 small, it means actually. When you specify machine type, you can specify machine types which is shared some physical machine, and there are machine type which promise you that you will have dedicated physical machine for this. That your image will be not collocated with other machines. It depends on machine type you specify here. Now, instead of containers, containers engine uses another abstraction called pods. Pod is a set of containers coupled together. Why we need them? Why we need this level of abstraction? It can be used to create a stack of
microservices.
No.
Different containers, each running gets separate
No. A pod, this is a component. Pod is a unit of autoscaling and unit of deployment. In microservice world, a pod this is an instance of your microservice. Single service. We'll talk about services on the next slide. But you can create two containers that we work closely each with other, and for example, web server and the log roller. You can put it in the same container. You can divide them between two containers. But when you create your pod, this is an example of configuration file. You provide a list of containers. And you can use one container, you can stack them together. But Containers Engine and Kubernetes will promise you that both these containers will be deployed together. Actually, I think in our pilot, we haven't used different containers in the same pod, but this is a
It enables you to control all the containers from single point also? let's say I want to shut down a bunch of containers, do I shut down the pod? And
you shut down the pod will shut down all containers. And
it's a management tool, more.
Yes, this is a management abstraction. Like you manage a set of containers, and management will take care that these containers always will be deployed together to the same machine. Okay. Once we created our cluster, we can we specify our pod. We indicate, we provide images of, Docker images, and now we can ask master node to create these pods. How we do it? gcloud preview, we provide cluster name, create, pod, and pod name, and config file. This is a config file which defines the desired state of our pod. What we have here, pod name, in order to reference this pod for management. Containers, we can limit the amount CPU usage for this container. And we have labels. Label is very important concept in Kubernetes. Labels allow us to group containers together, and we can group by, for example, microservice, which is, for example, if you have front-end microservice, and we have label of stage production. Now we can run management commands according to the label. We would like to select from whatever we run on the cluster, just front-end instances with production stage. Now we can select them, we can access them, we can destroy them, we can monitor them using labels. What we discussed before, we created our pods manually. We asked master node to create a pod, just a single instance of the pod. If you would like Kubernetes to manage and to monitor it automatically, we should use replication controller. Replication controller, this an instance, it is also service provided by Kubernetes that will create our pods according to specification we provide. We provide number of instances, replicas, and we provide templates. This is the definition of the pods that we would like to manage, and the pods and labels of this pod. For example, we can create a replication controller that will create us 4 instances of our backend microservice in production stage. And this application controller will monitor all of them and will make sure that we have in each time exactly 4 instances.
It's all of this running on the same pod, or it's replicating the pod itself?
Replicas is number of pods.
Okay. So it's not like, okay.
The command line to create is very similar to, like, it's a CRUD command for everything in Kubernetes, create configuration controller, and in configuration file, important parameters are number of instances, replicas, 7 in this case, and definition of pods to run. Service, another level of abstraction, and allows, it's very important, and this is something that we miss in managed VM. If in microservices architecture we have different instances of each service, and we we should access the service from other services, and how we find an address. We have for example, 4 instances of background services. Each of them has his own IP address, probably the same port. But if we would like now to open connection to background service from our front-end service, how we will find to which instance to connect, how we will find IP address, etc. Abstraction of service allow us to communicate, to create an entry point for TCP/IP communication with set of ports. In order to do this, we have to specify, to create an instance of the service, and to specify ID, port, and define by labels which ports are included to this service. We create the service in our cluster, and what we have now for this service, we have port and we have service name. Using the service name in this port, now we can communicate with all instances of this service from other pods. How we know? When master will deploy our containers, it will create environment variables for all services included to our cluster with service name and service port. Like service name _ service port, service host, it will be the host, and also now they have IP and port. And now from our application we can read a host IP and port of the external service we would like to communicate with, access. Kubernetes will load balance request to this server across all instances of this service we have. What else we can access from our service, from our container? We know the information about container itself. Host name, it will be a pod name. We can specify in our configuration file environment variables that we can read inside container itself. We have information about all services in our cluster. And also we have callbacks that can be implemented by shell commands or by HTTP requests. Today they have just 2 callbacks, poll start and press stop. They plan to do additional callbacks also for lifetime management and for metrics reporting and for health monitoring. And your application has to implement or have option to implement callback to these requests, and in order to interact with environment.
Do they provide some sort of tracing as well?
No.
No tracing.
No tracing, no logging, no monitoring. Today it's very close to, from ALM point of view, it's very close to compute engine. Actually, it was developed in the compute engine team. It's compute engine for containers. Okay, now what we did with this technology at Wix, we selected one Java-based microservice, which has var-based microservice, which doesn't communicate with other external services, and we try to run it on managed VM and on continuous engine. Managed VM, what we learned and what our current state and what we plan to do. Good news, it works. It works. We have a New Relic agent installed in it. It auto-scaled. We tested auto-scale with load. It works. Currently, it communicates with MongoDB, which we created an instance on Compute Engine. But on the next stage, we plan to migrate data to data store. It deployed. We do some basic tests, and we plan to move part of production traffic to it during next week. Right now, we don't have CI integration, like we deploy it manually. We plan to see what it makes to do CI integration in order to deploy it automatically.
Deployment is just command line?
Yes. And managed VM, in contrast to container engine, when you deploy a new version, you have in parallel your old version and the new version, and you have split traffic between them. And you can even choose which percentage of the traffic you want to redirect to a new version. And the way to upgrade your service is to create a new version and to move traffic or gradually or one time. In continuous engine, it's much more complicated. Actually, the way to upgrade your system now, you have to create a new replication controller with 0 instances to create, and now start to add the instance to new replication controller and remove instances from old application controllers.
Both controllers can live together?
Yes. But like you manage this traffic splitting on much lower level. In managed VM, you have version number and you have configuration, percentage of traffic to this number, and you have default. If you have default, all traffic will be redirected to this version. And now the next step, we plan to evaluate how managed VM logging, tracing, debugging, monitoring can help us, which part of New Relic can be replaced by managed VM monitoring, or we will have to stay with New Relic. This is something that we plan to continue to work on. The same pilot on continuous engine was blocked because lack of HTTPS support, and we need HTTPS for this service. Good news that just 2 days ago we received an email that HTTPS is now supported by continuous engine, and we probably will continue this pilot as well. That's all. If you have any questions, we'll be happy to answer. Thank you.